Hello, my name is Zhurakousky, and today we're going to talk about Spring Cloud Stream, what happened, what is happening, and what will happen in the future. Again, that's me. Here's my Twitter handle. That's where you can find me, Oleg Z on GitHub as well. And me, a little bit about myself. I've been with Spring organization since 2008. Started as a sort of a consultant trainer and then switched to engineering. Worked for many years on Spring integration project, and but now I'm basically a technical lead for two projects. One of them I'm going to be talking today about, which is Spring Cloud Stream, and also a Spring Cloud function. So here's our agenda. Like I said, Spring Cloud Stream is one of the frameworks that I'm working on. And today my goal is to give you a quick overview of the framework, its features, its benefits of using in conjunction with another framework called Spring Cloud Function. We're also going to concentrate on this new programming model of Java functions as stream handlers. Actually, it's not all that new. It's been around for about 4 years, but now since we released 4.0, the old programming model that we used before is completely removed. So in a way, it is kind of new for those who have been a long time users of Spring Cloud Stream. And with that, there's a lot of new things that came about, or certain things that have improved. And of course, we're going to talk about those new things that are coming or already here. So to begin, let's establish the context of our conversation by defining streaming and what do we mean by that. There are many different definitions out there and many different opinions. The one that we like, the one that fits our belief, is actually coming from Hazelcast, and I would like to credit them with this definition that I'm sort of stealing from them, which is event stream processing is the practice of taking action on a series of data points that originate from system that continuously creates data. That's what streaming is. So there are many different delivery mechanisms to produce these data points, which we also call events. An example of such a delivery mechanism could be, messaging system, some kind of a pops up mechanism, HTTP, sensors, you name it. So, and at the heart of streaming is the high-level processing pattern consisting of three core elements we call source, processor, and sink, essentially signifying a start, transit, and end of event processing within the stream. Source is usually where the origin of the events. Processor is where you perform some type of action on the event, and this is typically where developer spends most of their time, because this is really where the code is written. And sink is really the rest point for the data, not necessarily for the stream, but for that particular event, because the stream could continue indefinitely. However, for just to describe within the pattern, the source process sink, that kind of signifies beginning, transition, and end. So what is also important to understand is that in the source process sync paradigm or pattern, these components, and we'll see a slide down in a few slides. We'll see a slide that kind of shows this in a more physical way. It basically the important part to understand here is that the source processor and sink, they're not really connected directly between one another. There's a intermediate connectivity component in between them. Often represented as a channel, and the channel could be a messaging system, some kind of a pop-up mechanism, persistent or non-persistent, maybe HTTP REST endpoint or something along those lines. So, so there's many different ways to connect the system, but it brings a very interesting benefit is because of that, these components are completely decoupled from one another, which means that while one can continue to produce the data, another one could be, let's say, upgraded, because the component in between, then the messaging system, if it's a persistent one, it may start accumulating the data until the next component will be up and running and pick it up, and so on. So, and that brings us to Spring Cloud Stream, which is the framework that we're going to be talking about today, which is literally a framework that allows you to implement these components called source, process, and sync. The core abstraction, the framework started as a lot of different things, but right now, if somebody would ask me what is Spring Cloud Stream, I would say Spring Cloud Stream is basically a binding framework. The core component of the framework is a destination binder, which is essentially a component that helps us bind your code, the code that you write as a developer, to a variety of messaging systems. So essentially, an arrival of a message on a particular messaging system could serve as a trigger to invoke your code. And you, as a developer, would have nothing to do with that. You would just simply have to write a functional code and identify a couple of the dependencies, and things will start working. So we'll see. Like I said, I'm typically in my typical presentations, I do a little bit of slides, a little bit of coding. And even though this is 25 minutes, kind of a little short, but I'll still manage to show you a few live samples. So, as I said, the title of the presentation is sort of past, present, and future. So this is what we're looking at is the past. So this is how things were before. This is your typical Spring Cloud Stream application. For those of you who have been with Spring Cloud Stream, this code should look familiar. And for those of you who are new, you can disregard it because you'll never see it again. So as you can see, there's a lot of interesting annotations here. And this is essentially what we recognize as a problem, because it really is a Spring Cloud Stream application. It's not just an application, because there's a lot of tight coupling between configuration and functional code, as well as, and again, another problem is the configuration is not always just in code, or most likely is not just in code. It's mixed between the code and properties, so it's very difficult to sort of manage. So we recognize that as a problem, and we decide to fix it. We'll see it in a second. So again, a slide for those of you who have been using Spring Cloud Stream for a while now. Spring Cloud Stream is built on top of another framework that I mentioned earlier, which is Spring Integration, which defines its own set of annotations. But because Spring Integration is on the class path, you can still use Spring Integration annotations. Although I do not recommend it, but I just wanted to make a note that you can still use those, because those are controlled not by Spring Cloud Stream, but rather by Spring Integration itself. So Java functions. So when about a little over 4 years ago, when Dave Sire started a Spring Cloud function project and eventually handed off to me, I started looking at this project and realized quickly, because we already had several adapters within Spring Cloud Function, that we can actually do something similar on a Spring Cloud Stream side and reuse the same programming model within Spring Cloud Stream. And that was pretty much the beginning of migrating the annotation-based programming model with the stream listener, the slide that you saw before, to a functional-based programming model. And when I say function, I'm not talking about something new. I'm talking about something that we all should be familiar by now. Is the Java 8 function, Java utility function package, which is supplier function, consumer by function, and all those interfaces. So, and you can also see that the supplier function and consumer maps pretty much one-to-one to this pattern of source, processor, and sync. And this is the physical diagram that I promised you earlier. So again, this is clearly shows you that this source, processor, sync, so in this case, supplier function and consumer, they don't necessarily connect it to one another directly. They are connected through some type of connectivity mechanism that allows, and typically right now, and what I'm going to show you today is going to be a pub sub, which means that not only they're decoupled from one another, the main benefit is that not every component within a stream should be up and running for the stream to exist, because these components right here that are backed by a messaging system will store the data until the next component, the next subscriber, is available to start processing the data, and so on. So, and this is the present. So this is what the typical application, a very vanilla Spring Cloud Stream application looks like. As you can see from this code, it's not really a Spring Cloud Stream application. It's just a Spring Boot application. So this is the interesting part, because this is the kind of the goal that we were trying to end up with, which is say, listen, in the best traditions of Spring Boot, this Spring Boot application only takes the flavor if you look at the PUM file and see what kind of dependencies are there, because those dependencies are not just the libraries, they're auto configuration, which means that this function bean could be a message handler, could be a REST endpoint, could be many different things, but you cannot determine it from just the code. The code is clean from all non-functional requirements. So it's just a bootstrapping Spring application context with the 2 uppercase bean in it. And you need to look at the PUM file and other configuration elements, if there are any, to determine what type of application this is. So, quick demo. So I'm going to switch to the IDE on time. We're doing well. So again, there's a lot of commented code, so bear with me because I'm going to reuse the same piece of code for various different parts of the demo. But right now, we're going to go with a very vanilla example. Now, there's nothing in the external configurations because every property that I'm going to be providing, I'm going to provide it here in line, so we can only see it on one screen. But typically, we provide properties in the YAML file or application to the properties and so on and so forth. So in this case, we have a Spring Boot application, just as you saw on the screen, and an uppercase bean in it. There's nothing else in there that is relevant. Okay, so we're going to start it. And application is running. So we're going to go to Rabbit console. So we see uppercase binding created for us. I'm going to say hello. And you can see uppercasing hello. So basically, all I did is implemented a simple Java function. Okay, I implemented as just a lambda because it's very trivial. And that's it. So if we want to understand better what happened, like I said before, we need to look at the PUM file. And within the PUM file, we see that we're using Spring Cloud Stream binder Rabbit, so which means we're going to be using RabbitMQ. RabbitMQ is what's connecting us, and this is what I was doing here. I was sending messages via RabbitMQ, and that's it. Okay, so that's how you can tell what this application doing, because as you can see even from the class path, you can't really say from the import declarations, you can't really say much of anything about what this application is doing. So back to the slides. So now let's talk quickly about this the new features that are coming, and the new features that are coming or that are already here that you can benefit from. So one of the biggest benefits of using Java functions in general is function composition, right? So of course we provide function composition, and you can, in a configuration, you can do it using a pipe symbol. Now the benefit, you can see example right here, but you can say definition, uppercase, reverse print, and you basically reassemble all 3 functions into a single function. The benefit of using Spring Cloud function is that we provide a bit of extra. So for example, composed and composable. So in a pure Java function composition, you cannot compose function and consumer, right? But with us, you can, because, for example, composing function and consumer, the end result is just a consumer. The same goes for supplier and a function. The result is still a supplier. So also incompatible input and output, because we provide transparent type conversion. So for example, in this case, if you try to compose Java uppercase and print, let's say a print was a function with taking input as a person. If you try to compose these two, it would give a compile error because the output of string cannot be composed with the input type person. However, with Spring Cloud function, you can do that because we provide this internal way of configuring composing this type of components. Of course, reactive and non-reactive functions, and so on and so forth. So again, I cannot describe all the features, all the bells and whistles, but these are the most important ones. Okay, so binding and binding names. This is important. If you remember the slide with the stream listener, for those of you who have used Spring Cloud Stream before, bindings, you have been responsible for providing a binding. So you would have to do enable binding. You would have to either use the 3 binding interfaces that we provided for you, like source, processor, and sync, or create your own. But it is something that you would have to manage yourself every time you create a Spring Cloud Stream application. Right now, you don't have to do anything at all. Binding names are implicit. They derive from the function name. So for example, if you have function name uppercase, the binding name will be uppercase in 0. In fact, I'm going to quickly switch to the Rabbit. I'm still running my application. You can see in the exchanges, uppercase in 0, uppercase out 0. Those are the binding names, right? And binding names are basically are important because this is the abstraction that you as a developer typically interact with. Because we made a mistake by in an annotation-based programming model, exposing you to the concept of channels and everything. That's an internal implementation, and not every binder supports the channel-based implementations, which means it created a bit of a disconnect where every binder that's out there has a binding, and that's the abstraction that you typically as a developer have to work with. So a little more on the binding and binding name. So of course, it's very convenient when you have a single function and you have this binding name like uppercase in 0. Now, quickly, in, out, obviously corresponds to input and output. 0 corresponds to because it corresponds to the first input or the first output. The reason for that, for 99% of the applications, it's always going to be 0. We do support functions with multiple inputs and multiple outputs, and only for those, and those are reactive functions, and only those functions would have in 1, in 2, in 3, and so on and so forth. But it's a very rarely used feature. So typically it would be in 0, out 0 for you guys. So, okay, going back to this slide. So we do have uppercase in 0 and like a binding name. And now you can see how you can use this binding name as part of your binding configurations for other properties of this particular binding. However, in the case of function composition, those binding names could become very unreadable, like you see an example right here, where we compose uppercase, reverse, and print function into 1. The binding name becomes uppercase, reverse, print in 0, which is basically one unreadable name. So you can still use it, no harm. But if you want to make your life a little simpler, you can quickly map it to something more readable. So in this case, you using Spring Cloud Stream function bindings, uppercase, reverse, print in 0, you map this binding to the word input, and now you can use that word input in place of that encryptic name. Simple as that. Now, by function support. So a lot of times in the previous version, you would have to use something like this. Well, again, this is service activator. This is a Spring integration annotation. You can still do it today. But again, you're coupling your application to a particular framework because now you have the service activator annotation, add payload annotation, add header annotation. So these are the framework specific annotations that make your code sort of a little dirty because it mixes functional and non-functional aspects within your code. So now, the reason for that is because let's say you want to deal with metadata, and the metadata comes in the form of a message. You could also take a function and say the input type will be a message, and we'll give you the entire message. You can extract the headers and payload yourself. Again, it's not the cleanest approach because now you have to deal with the message, which is again more of a framework abstraction, right? So what can you do to emulate this model that I'm showing right here? So, and that is basically used by function, again from Java function. And the signature in this case, unlike any other function, the signature here is very strictly controlled. It should be any kind of object as the first argument and always a map as a second argument, because the map would represent the header. So effectively, you're asking me for a message, but say, give me payload and headers separately. So that's all it is. So demo, we're going to skip the demo because we'll press for time now. Like I said, once I get to the end, I'll see how much time I have. I'll run through some other demos. So a routing function. So another very interesting feature that that people are using more and more often, even though it started from a completely different use case from actually Spring Cloud function on AWS, but it's becoming more and more popular within stream processing, which is ability to have a single function and then have that function route your data to different functions within your application context. So there are several mechanisms to enable. I'm just showing you one. For example, Spring Cloud Stream function routing enabled equals true will result in binding. So for example, that I'm going to show it to you real quick. So, for example, right now I don't define Spring Cloud function definition. I just simply define a I'm going to define a couple of functions. So unblock. Okay, so now we have application our application. We just define sprinkler stream function routing enabled equals true, and we're done. So I'm going to start this application again. We go back to router console, and we can see that we have function router in a binding created. So now we can send a message hello, and we expect the error. Right, because the error says that failed to establish routes since neither were provided. So the error message actually tells you what's missing. So it says provide sprinkler function definition as a message header, or that, or that, or that. So we're going to do this uppercase hello, and now everything works. Uppercasing hello, or if we're going to say, was it to JSON, we can see to JSON hello, result name hello. So we can see how we can do all these different things. And that's kind of shows you quickly the function, the event routing. So we have several mechanisms. We have several mechanisms that you can implement routing. So what I just use is the option 2 right here, which is the providing sprinkler function definition as part of the message header. You can also provide it as part of a system property. You can also provide it as use routing expression and provide, in this case, I'm saying extract the function name from a header called function name. If you really have a complicated logic that you need to, call the database or something like this, then the most preferred way is to implement message routing callback. All you need to do is implement this interface, define it as a bean, and that's it, because we're going to look for it. And if we find it, we're going to use it. It takes priority over everything else. And then you can have a routing logic for pretty much every possible condition that you have. Demo I already showed you. Stream bridge. Another interesting story within Spring Cloud Stream. Marcin Grzesiak, a guy from Spring Cloud team, my dear colleague and friend, who is lead for Spring Cloud contract project, called me one day. He explained me his use case, so I effectively created a component for him. But right now, it's one of the most popular components in Spring Cloud Stream. And what this component does is bridging Spring Cloud Stream with other framework. Again, it's worthy of a quick demo. So, for example, yeah, let's do this. So I'm going to start this application again and show you something really cool. So what I didn't show you in the class path, what I also have here is I also have some Sprinkler function web dependencies, right? And which means that my application not only has a flavor of a Sprinkler stream, but it also has a flavor of a REST endpoint. So what I'm going to do now is I'm going to go and say localhost 80 log and print. Is it how it's spelled? Let me just see quickly. Log and send. Log and send Oleg. Oh, what happened? Oh, okay, so let's just simplify it a little bit. Okay, let's start it again. Okay, I have 3 minutes. So let's do it again. And we can see received Oleg and sent Oleg to foo. Now, if I go back to Rabbit, we can see that the foo exchange was created because we sent it to foo, and the Rabbit provisioning, the Sprinkler stream provisioning mechanism, the binder says, okay, I don't have any bindings for foo, so I'm going to create one and define destination within the RabbitMQ. And the same would happen with Kafka, the same would happen with Solus or any other messaging framework that has a binder provided. So where are we? But okay, so we're here. Now, content enrichment. Again, we'll press for time. So content enrichment is the mechanism to allow you to enrich the content. Now, you can always do it with a function composition. That's a very easy thing to do. But if you have something as trivial as just augmenting the header or adding a header or removing the header, you can simply use this sprinkler function configuration binding name or function name, and then input header mapping or output header mapping expression, and provide a spell expression that will help you to do that simple trivial task. Again, this requirement came out from a Solus guys. So error handling, again, error handling right now is very simple. All you need to do is before you had to know the convention for channel names and subscribe to a particular channel. Right now, you don't have to know anything other than just a simple way of creating a consumer to handle your error, and then define a property that for this binding called uppercase in0, error handling definition is going to be my error handler. So which means that if this function fails, then the error handler is going to be this consumer, and you put your code in here, and you can see that you'll receive an error message from which you can extract the original error message or print stack trace or do whatever it is you want to do. 1 minute left. So post-processing, this is the newest feature. In fact, it's still on the snapshot, but it's coming in the next 403 release, which is the ability to post-process function. Again, this is very important to understand what this actually really means, and I'm glad I was able to get to this point. With post-processing, you can say, okay, I can compose another function to the end of the function and do some post-processing. That's not exactly true in the context of streaming, because the context of streaming, the end of the event processing means that the event has been sent down to a messaging system. So if you do it as a pure function composition, the function is going to be composed with another function, and your post-processing will occur before the event is going to be sent to the destination. So what this does is what this mechanism does is allow you to provide a function that that allow you to actually do this post-factum, post-send. So this is going to be the last demo that I'm going to do. And it's very easy to do so. I already have the code here. So this is the implementation of this post-processing function. So in this case, it's a reverse, right? So let's just simplify, say reverse, and we're going to say return new what we call it. So the definition is going to be reverse, and so I'm going to start. So, and now I can go back. I have my reverse queue. I'm going to say hello, and we can see post-processing occurred, and here's my hello and reverse already been done. But this has been, post-processing has happened after that. Now, here's the last trick I wanted to show you. So in this case, I have to input, so one way to do it is you can implement this thing, right? This post-processing function. Another way is to do nothing, because we provide the full implementation, which will simply pass through. Will return the same input that it was sent, right? But only implement post-process method. So now what you can do is you can say, listen, you can do, I want to steal the code from here. You can do return but now you can say you can have a function called post-process, which will return this reverse post-processor. Of course, it would be called differently, but now you have a generic post-processor. What you can do is say this pipe, which is composition, and post-process. So in this case, you are doing composition, so it will invoke the apply method of a post-process, but that apply method does nothing. Now, after the message is going to be sent, it's going to go back to post-process function and invoke its post-process method, and that's really your post-processing. So in other words, you can do it this way, like you can either implement the actual post-processor function and do apply and post-process in a single function, or you can do it this way. The main point is that apply is going to be invoked as part of the whole function composition, and post-process is going to be invoked by Spring Cloud Stream only after the message has been successfully sent. So with that, I believe I'm out of time. And quite frankly, I have finished. There's a couple of gotchas that I wanted to quickly show you is that always define, I'm going to share the slide deck, always define sprinkler function definition property, even though for simple demos, it's not required. Reactive function issue with error handling retries and sudden stops. This is often asked and well documented. Reactive function is not a message handler, so it's initialization function invoked only once at the beginning and connects to streams. That's it. So we have no control over it. And again, reactive functions with non-reactive binders like Solus, Kafka, Rabbit, they don't bring you full feature of reactive API. So be careful when you use those type of abstractions. With that, I thank you very much. These are the tools that we have used today, and we're done. Thank you so much.